Hi, Jack.
Hey, welcome, Richard.
Thank you.
Thanks for your interest in the Prisma project. I'm first going to give you some introduction what the Prisma project is about, and then I would like to show you a demo of what we actually realized in the Prisma project, just a small part. Okay, first, let me introduce Prisma. Prisma is a collaboration with Philips Lighting to work on the tooling on developing lighting systems. We don't do that alone. We use our other TNO Easy projects for inputs. We use academic inputs from the technical universities. We use inputs from the Open Eyes project. That's actually a European project in which all kinds of partners of the complete lighting system, installers, commissioners, and system designers are in. And we're also focusing on what's now hot is big data, data analysis, trying to capture data in there, and there are also lots of industrial partners with which we can do that. So that's a bit about the ecosystem we live in. Now about what we're trying to do. We're trying to introduce a new methodology to develop and analyze these lighting systems. And we do that in the language of the stakeholders. We try to specify a lighting system with different languages. A language for the stakeholder of the builder of the building. So he speaks in his terms, so it's about rooms and walls and light points. We also have a network specialist in there who talk about the network, what kind of components do you need in there to set it up. We have the lighting system designers on board, which have their own language to specify lighting behavior in a building. And we put all these models together, which you can make with these languages, to specify the complete lighting system. Now, if you have these models, you can do lots of fun stuff with them. So what we do with them is we can do some experiments. We have a virtual prototype where you can input scenarios of people walking through buildings and then see how the actual lighting in the building, how that works, if the behavior is correct. But you can also do with these models, you can do formal verification. So you can see whether there are deadlocks in the system, whether your latencies are okay. So if you press the button, the light should go on
within a certain time.
400 milliseconds or something. Mm-hmm. So you can upfront with these models analyze that and see whether the lighting system behaves like the way you want it. And the fun part, of course, is that you also can generate code from it. So that's also a thing that Philips Lighting likes a lot. For each device, you generate the code. You don't have to do it manually again. You just push the button from these models, you get the right code in your devices. So that's the fun stuff. In our demo, which I'm going to give you, we're focusing on a virtual prototype showing a visualization of the behavior in the building. We are actually going to do a proof of concept with a real building.
Wow.
So in Eindhoven we have the White Lady building. It's a former Philips Lighting factory. We're going to put our light system in the 5th floor. It's about 400 luminaires, light points in there with sensors. We're going to put a nice new lighting system in there. And the purpose is that to get energy savings. Mm-hmm. But the challenge is also we cannot modify the building. It's a historic building. We cannot put cables in there, so we have to do it with the infrastructure that is there and put new devices in there. So lots of wireless stuff.
So you use the actual domain specific modeling approach?
Yeah, actually we made building models for this one, behavior models for the light system designer, and we can visualize that. Okay. And that's what I'm going to show you next. But first I want to tell you a bit about the languages we use, so you get an idea how it works. So we have a model of the lighting system, where you see the building DSL, the building language. We have a template language for the behaviors. We have a control language to map behavior on light.
So you join them in this?
Yes. Okay. So it's an abstract model. It doesn't say anything about the devices actually used. So you can use these models for more than one technology. When you have this, you want to add stimuli to the system. So you have the lighting system modeled, but you also want to model scenarios, people triggering sensors.
So the environment of the system.
Yes.
That's what you want to do.
So you want to do that here, and together with the system model, we define an experiment where we say, okay, we have these people running through that building with that specification, and we can generate a co-simulation framework from that with a visualization in there, which we're going to see in the demo.
Okay.
So how does what is in a building model? The building model specifies the rooms. You see that here. We have 7 rooms and we have a corridor. And for each room you can specify actuators, these nice sun-like icons. We have sensors, presence sensors, detecting people, but we also have buttons. You can specify that all in your building model. Now we come to behavior. We specify behavior independent of how many lights or sensors are used. It doesn't say something about rooms or anything, it's just a behavior description. And I want to show you one of these behaviors which we implemented. It's called an open plan. And you see a room here where the open plan template is deployed. Someone entering the room gets detected by the presence sensor, and the open plan says, if I detect someone in the room, then I put the light where the presence was detected, I put it on 100%, and on the other lights in the room, we put it on 50%. That's a comfort template, so that people the man is not sitting in the dark. So the room is lit, not completely, but partly. And then he moves to his actual workspace, gets detected there, that light turns on 100%, and after a while, the light on the bottom will turn to 50% like the other lights. So it's a comfort level. If he disappears mysteriously, now he disappears, then he will no longer be detected. There is no one in the room, the lights go off. So you get energy saving by the lights turning off. That's the open plan template. We have lots more templates. In the demo we have a cell office behavior and we have a corridor behavior, but we'll see that in the demo. Now we're gonna put these templates on an actual building. So we have a building model, we have a template model, and now the control model maps actual devices to templates. And what we see here is that the top 3 and the bottom right will have an open plan template. That's the one I described before. We will have meeting rooms. That's another template, and over that we will have corridor linking, and that's what the demo will be about. So we'll see that in the demo. How does the model look like? It's text-based, so it's quite verbose, but in this way you can specify the mapping of the templates to the devices. Okay, now the demo part. You see a picture of the White Lady East Wing. We built the building model for that. We also created some templates which we're going to apply in that building, and you can see them on the bottom. We have an open plan, we have a corridor, we have a cell office, and we have a meeting room template.
Okay. Yeah.
And in the picture you see where we're going to deploy, on what devices we are going to deploy that. And we are focusing on the top left of the building because I have to zoom in a bit in the demo. We have a corridor, we have an open plan, the one we saw before, and we have a cell office. Now that is the initially commissioned behavior, how the wing will behave, the lighting behavior. And we're going to show that using this model-based approach, switching to another deployment,
To other behavior?
other behavior in the system is as easy as changing one line of code in the model. So this way it's quite easy to do that. And the newly commissioned behavior is a so-called corridor linking behavior, which means that if you enter the corridor, the lights in the corridor will turn on 100%. If you enter a room which is linked to the corridor will never go out completely, the light. It's also a comfort setting that you don't look into black space, and the light level will stay on 50% as long as someone is in one of the linked offices. If no one is there, then the light goes off in the corridor. And that's what I'm now going to demo. Okay, so now we're at the demo itself. So you're going to get a live demo. What you're looking at is, again, the east wing of the White Lady with all the luminaires and the sensors, as you can see. And it's commissioned with the initial behavior. So you have the corridor behavior, which is not linked to the offices. So I will zoom in now on the top left area, which I already explained to see it more clearly. So now I'm a person, I'm entering the building. You can see it here, yes. Okay. And a sensor gets triggered. You see that the lights in the corridor will turn on. Now, if I wait 10 seconds, the lights will turn off. There's no one detected anymore. But we have the scenario, we enter the corridor and we go to our working space, as I explained in the presentation. You see that the light turns 100% here and the other places 50%. I walk to my actual room. This workspace gets 100%, this one 50%. You see that the lights turn off in the corridor, so it's independent of, if I go here, no lights will turn on in the corridor, so there is no linking between the rooms. And we're now going to change the control model to use the template for the linked corridor. Okay, so I have to switch to development environment. I'll show you where the difference is. So I have opened the control model for the initial commissioning on the left side and the recommissioning on the right side.
So one of those blue boxes of the presentation.
Yes, correct. So that is the mapping behavior on building. And we see that for this corridor, that's the large one we saw, we changed the template from only corridor behavior to linked corridor behavior. So that's where the difference is going to be. Let me first disconnect this visualization. I have to stop the simulation, and then we're going to do the magic. So we're going to the recommissioning models, and I already changed the text, but I have to start the generation, and we do that from the experiment. I have to make a change there. And then if you look on the left side, there is nothing generated yet, but if I now press save, you see there is a source gen folder in which all simulators required for the co-simulation are generated by just one change and a click on the button. Now we're going to run this one. Okay, so now I switch to the visualization again. I connect it to the co-simulation framework. Okay, now we do the same scenario.
Okay.
So person walking into the corridor.
Triggering the sensor.
Yes, correct. So the whole corridor turns on, and I work to my workspace here. We see the lights go on. And then I go to my initial workspace. And you see,
I see it. Yeah.
Lights are now 50%. So by just making one small change, pushing the button, code gets generated for every device with the new behavior in there.
For the whole building?
For the whole building, yes. And if the person leaves the room, magically all lights turn off, which results in an energy saving.
Okay. Very nice. Very nice.
Okay, that finishes the demo part. So what have we been looking at? We have shown that this domain model-centric approach helps Philips Lighting in easily defining lighting systems in the stakeholders' languages. So not in a C language, stakeholders' language, building, template, behaviors. We also see that it enables the development of highly scalable distributed systems in models. And with these models we can do various interesting stuff like generating this virtual prototyping environment. We can do formal analysis, we didn't show it here, but we can do it. And we can also automatically generate the code. So no more testing every single line of manually written code, just once writing the code and push the button.
Very nice.
Yeah.
Impressive, thank you.
Thank you.